The increasing potential intensity associated with global warming as predicted by global climate models, Emmanuel 1987, is consistent with the increase in modeled storm intensities in a warmer climate, as might be expected, Knudsen and Tulia 2004. But while observations of tropical and subtropical sea surface temperature have shown an overall increase of about 0.2 degrees Celsius over the past 50 years, there is only weak evidence of a systematic increase in potential intensity, Bister and Emmanuel 2002, Free et al. 2004. Emmanuel, 2005, reports a very substantial upward trend in power dissipation, i.e., the sum over the lifetime of the storm of the maximum wind speed cubed, in the North Atlantic and western North Pacific, with a near doubling over the past 50 years, Webster et al. 2005. The precise causation for this trend is not yet clear. Moreover, in the North Atlantic, much of the recent upward trend in Atlantic storm frequency and intensity can be attributed to large multi-decadal fluctuations. Emmanuel, 2005, has just been published as of this writing and is certain to motivate a healthy and robust debate in the community. Other studies that have addressed tropical cyclone intensity variations, Lancy et al. 1999, Chan and Liu 2004, show no significant secular trends during the decades of reliable records. Because the global Earth system is highly complicated, until a relationship between actual storm intensity and tropical climate change is clearly demonstrated and accepted by the broader community, it would be premature to conclude with certainty that such a link exists or is significant, from the standpoints of either event or outcome risk, in the context of variability. Additionally, any such relationship between trends in sea surface temperature and various measures of tropical cyclone intensity would not necessarily mean that the storms of 2004 or 2005 or their associated damages could be attributed directly or indirectly to increasing greenhouse gas emissions. Looking to the future, global modeling studies suggest the potential for relatively small changes in tropical cyclone intensities related to global warming. Early theoretical work suggested an increase of about 10% in wind speed for a 2 degrees Celsius increase in tropical sea surface temperature, Emmanuel 1987. A 2004 study from the Geophysical Fluid Dynamics Laboratory in Princeton, New Jersey, that utilized a mesoscale model downscaled from coupled global climate model runs indicated the possibility of a 5% increase in the wind speeds of hurricanes by 2080, Knudsen and Tulia 2004, cf. Houghton et al. 2001. Michaels et al. 2005, suggests that even this 5% increase may be overstated, and that a more realistic projection is on the order of only half of that amount. Even if one accepts that the Knudsen and Tulia results are in the right ballpark, these would imply that changes to hurricane wind speeds on the order of 0.5 to 1.0 meters s1 may be occurring today. This value is exceedingly small in the context of, for example, the more than doubling in numbers of major hurricanes between quiet and active decadal periods in the Atlantic, Goldenberg et al. 2001. Moreover, such a change in intensities would not be observable with today's combination of aircraft reconnaissance and satellite-based intensity estimates, which only resolves wind speeds of individual tropical cyclones to at best 2.5 meters s-1 increments. Understanding of trends and projections in tropical cyclone frequencies and intensities takes on a different perspective when considered in the context of rapidly growing societal vulnerability to storm impacts, Pelkey and Pelkey 1997, Poulwardy and Rivesame 1997. There is overwhelming evidence that the most significant factor underlying trends and projections associated with hurricane impacts on society is societal vulnerability to those impacts, and not the trends or variation in the storms themselves. Pelkey and Lancy 1998. Growing population and wealth in exposed coastal locations guarantee increased economic damage in coming years, regardless of the details of future patterns of intensity or frequency, Pelkey et al. 2000. Tropical cyclones will also result in death and suffering, in less developed countries in particular, as seen in Haiti during Hurricane Jeanne, cf. Pelkey et al. 2003. Over the long term, the effects of changes in society dwarf the effects of any projected changes in tropical cyclones according to research based on assumptions of the Intergovernmental Panel on Climate Change, IPCC, the scientific organization convened to report on the science of climate change. By 2050, for every additional dollar in damage that the IPCC expects to result from the effects of global warming on tropical cyclones, we should expect between $22 and $60 of increase in damage due to population growth and wealth, Pelkey et al. 2000. The primary factors that govern the magnitude and patterns of future damages and causalities are how society develops and prepares for storms rather than any presently conceivable future changes in the frequency and intensity of the storms, see Figure 8. Flooding at coastal area. Consider that if per capita wealth and population grow at a combined 5% per year, this implies a doubling in the real costs of hurricanes about every 15 years. In such a context, any climate trend would have to be quite large to be discernible in the impacts record. With no trend identified in various metrics of hurricane damage over the 20th century, Pelkey and Lansey 1998, it is exceedingly unlikely that scientists will identify large changes in historical storm behavior that have significant societal implications. In addition, looking to the future, until scientists conclude that there will be changes to storms that are significantly larger than observed in the past, that such changes are correlated to measures of societal impact, and that the effects of such changes are significant in the context of inexorable growth in population and property at risk, then it is reasonable to conclude that the significance of any connection of human-caused climate change to hurricane impacts necessarily has been and will continue to be exceedingly small. Thus a great irony here is that invoking the modulation of future hurricanes to justify energy policies to mitigate climate change may prove counterproductive. Not only does this provide a great opening for criticism of the underlying scientific reasoning, it leads to advocacy of policies that simply will not be effective with respect to addressing future hurricane impacts. There are much better ways to deal with the threat of hurricanes than with energy policies, for example, Pelkey and Pelkey 1997. There are also much better ways to justify climate mitigation policies than with hurricanes, for example, Rayner 2004, with energy policies, for example, Pelkey and Pelkey 1997, and to justify climate mitigation policies than with hurricanes, for example, Rayner 2004. With the last hurricane to directly hit New York City dating back to the 1800s, residents have so far lacked the impetus to demand concrete strategies for dealing with the potential devastation to housing, the subway system and the electrical infrastructure from a major modern-day storm. Now Hurricane Sandy threatens major flooding from a storm surge that could reach up to 14 feet above the average sea level here. Some scientists suggested on Monday 29 October 2012 that once New Yorkers have moved to higher ground and weathered the hurricane, they should begin to take more decisive steps to adapt to more of the same. As it was reported last month, pressure has been growing for aggressive action as shown in Figure 9. Awaiting an onslaught, wave activity at Rockaway Beach on Monday morning, when Hurricane Sandy was 425 miles southeast of New York City, October 29, 2012. It is small comfort to sodden and stranded New Yorkers that Hurricane Sandy's flooding of the city's infrastructure, from power lines to subways to low-lying communities, was predicted in grimly precise detail by scientists in the latest state and city climate studies. Deeper and more frequent flooding from Rockaway to Lower Manhattan and the city's transit tunnels has been a repeated warning that largely went unnoticed by the public and most politicians. But now, with the floods from Sandy and Tropical Storm Irene last year on his watch, Governor Andrew Cuomo is pointedly stressing what he considers the inevitability of more such disasters. Climate change is reality, the governor said on Wednesday 31 October 2012, estimating Sandy's economic damage up to $6 billion. Given the frequency of these extreme weather situations that we've had, and I believe that it's an increasing frequency, for us to sit here today and say this is a once in a generation and it's not going to happen again, I think would be short-sighted. Mr. Cuomo admits that he does not have all the answers nor enough government money for all the proposed solutions. And we can all hope that he is wrong in his forecast. But the urgency of his warning is rooted in a basic fact of nature underpinning the government studies. New York's coastal waters, which rose an inch per decade in the last century, are heading toward rates of 6 inches per decade as the oceans warm and expand. That would be a disastrous rise of 2 feet across the next 40 years, for anyone planning ahead,